Alright, so today we are going to be learning Module 3, Lesson 4. We're also going to be going over the homework for Module 3, Lesson 3. Okay, so starting out here, this was our do now. The first two you had to do keep, change, because it was a subtraction sign here. So the subtraction is what tells you to do that. So I started drawing these lines with some of the classes. And that really did seem to help. Sorry, that one was really messy. So I'll draw them again. So you notice the line includes one number and the symbol before it. So 2x is one section, plus 5 is one section, but the subtraction is always by itself. And then 3x, and then plus 2 is one section. So we're going to keep, change. Okay, so that's going to become 2x plus 5 plus negative 3x minus 2. Okay, this is just going to make everything so much easier. After we do that, you can either stack them or you can use boxes and circles. Okay, so I have boxes. These are like terms. So I add them. 2x plus a negative 3x. So 2 plus negative 3 gives you a negative 1. So it's negative 1x. And then you have plus 5 minus 2. So 5 minus 2 is going to give you a positive 3. So this can be left just like this, or if you wanted to drop that 1, you're allowed to write it like that too. Okay? So 2, again, keep, change. Okay? So you're going to do 3x minus 9 plus positive 8x plus 7. Okay, so my boxes are my 3x and my plus 8x. Notice how the symbol's in there. 3 plus 8 is going to give you 11x. And my circles are minus 9 plus 7. So you can think about this as negative 9 plus 7. And that's going to be different signs subtract. So 9 minus 7 is 2. You keep the sign of the larger number. So this can be written two ways. You can either write it as minus 2, or you can do plus a negative 2. Those are both equal, so you can do either one of those. Okay, moving on to 3. So this is already addition, so I can just box and circle straight from here. I don't need to do anything more. So I have 6x and plus x. So this x is a 1x, even though we don't write it, it's the same. So it's going to be a 7x, and they have minus 2 plus 9. So negative 2 plus 9 is what it ends up being, which is a positive 7 because the 9 is bigger. So plus 7. Okay, 4 box negative x plus 4x. Okay, so negative 1x plus 4x. Okay, just do a little work here if we need to. Negative 1 plus 4 is going to be a positive 3. Okay, so 3x. And then you have plus 4 minus 3. So 4 minus 3 is going to be 1. So it's just plus 1. Okay. So this can go back into your do now section. Take a moment, take out your homework because we're going to go over that next. So the homework is already completed for you. Not for you, but for you to look at on here. I'm just going to talk you through it. Okay. So oh, the numbering's all kind of weird, but 2a, that's funky, but that's okay. So write two equivalent expressions that represent the rectangular array below. So the first expression is the 3 times 2a plus 5. This is kind of like thinking this is area as length times width, and these are added. And then you can actually multiply these out. So 2a times 3 is 6a, and 3 times 5 is 15. And that gives you your second. So this is your first expression. That's your second expression, and they are equivalent. They are equal in value, equivalent. All right, and then you have b. So we distributed the 3 out to the 2x. We did 3 times 2x, and we got 6x. That's the blue work. And then the red work, 3 times 5. So we keep our plus the same, and 3 times 5 is going to give us 15. So this is our equivalent term. They then wanted you to verify informally or prove, and then you're going to pick an x value for that. So I just chose x equals 2. You could have picked any other x. and you plug it in here. So it's going to be 2 here, so 2 times 2. Order operations has to do that first, plus 5, then times 3. Here I use this one. 2 goes here, so 6 times 2 is 12, plus your 15 is 27. So that checks out. So that means that 6x plus 15 was actually correct, and it is equivalent. All right, so for A and B, wanted to use that rectangular array again. So that means our first number goes right here. And the x plus 10 goes here. Okay? So 2 times x is 2x. 2 times 10 is 20. So it's going to be 2x plus 20. You can use this box anytime you want, or you can do it without like we did down here. Either way, it's still the distributive property. It's still the same idea. B, same thing. We just have one extra box. So 3 times 4b, 3 times 12c, 3 times 11, and they're added together because they were all added here. So you keep the same signs that you originally had. You're not going to make them up. You're not going to change them. You're going to use the same signs. Okay, so when we move on to this last chunk here, the same thing's going to happen. So 10 times b is 10b. You keep your plus, because that was a plus there. And you're going to do 10 times 4c, which is 40c. Okay, b, 9 times g, minus 9 times 5h. 7 times 4, 28n. Keep your minus. 7 times 5. Keep your m, minus 7 times 2. Okay. Here, this one, I think a few people got confused on this one. A times b is ab. That's it. Okay. Plus ac plus 1a, which is the same as just a. So whether you do this top answer here or this bottom answer, they're both equivalent. They're both correct. You'll see that a lot with this. I mean, that's technically the unit we're working on right now is equivalent expressions. So we're getting out things that are equal, that are the same. Okay. So E through H, this one was dividing. So I actually rewrote all these division problems like fractions because I like working with fractions better. So we get 48p plus 24 divided by 6. So I did circles like this. They kind of look like hearts to show you what I'm doing. I do 48p divided by 6. So 48 divided by 6 is 8. We keep the p, plus 24 divided by 6 is 4. So the plus stayed the same, and then I did 4. Okay, so here, 2b divided by 2 is 1b, or just b, plus 12 divided by 2 is 6. Okay, 20r divided by 4 is 5r, minus 8 divided by 4 is 2. And last one, 49g divided by 7 is 7g, minus 7 divided by 7, which is 1. Okay. All right, so moving on from here, we are on Module 3, Lesson 4 now. So take that out. I didn't take it out too, apparently. I thought I had it out already. There we go. Okay, so this first section here, A through D is actually just reviewing. This is just distributing like you had done for homework. So 2 times x is 2x. 2 times 5 is 10. We keep our plus, okay? I like using different colors for this. You don't have to. Last one I'll do is D, but you're going to have to finish B and C. 7 times x is 7x minus 7 times 3 is 21. Okay? So make sure you go ahead and do B and C after. But now we're going to be working in the opposite direction. So we want a number times an expression. Okay, a number times an expression. The way you're going to do that is find the GCF. The greatest common factor. That's why we did that last week. After that, you're going to write that out front. And after you write that out front, you're going to divide the GCF out of the other terms. So in the end, the standard form we want our answer to be in, when we're working in the opposite direction, is some blank, blank, plus or minus, doesn't matter, blank. So this is our GCF here, and these are the numbers after you divided them out of the original. Okay. So what I mean by that, I look at 5 and I look at 30 and I look for the greatest common factor. So if you need to list out all your factors for these, like we did on that homework, you can. 5 is just 1 and 5. 30 is 1, 2, 3, 5, 6, 10, 15, and 30. So greatest common factor is 5. So I'm going to write it out like this first. So I kept plus because that was a plus. My GCF is 5. So I write it out front. Okay. To fill this next one in, I'm going to do 5x divided by 5, and I get 1x. And then 30 divided by that 5 to get 6. Because what should happen is if I work backwards and I distribute it out, you're going to get back here. You don't want to work backwards though. You want to keep it like this because this is what we're looking for. This is now a product because now it's multiplication. Okay. So we're going to do this one here. So we have 8 and 8. Your greatest common factor is just that 8. Okay. So we're going to write it with the same format, blank, like this. It's a plus again because this is a plus. So we put our 8 out front. If we divide an 8 out of 8x, it does not become 0. It becomes 1x or just x. And then 8 out of 8 becomes 1. It doesn't just disappear. Those ones have to be there. Makes it entirely different if they're not. Okay. All right. Again, here. So you have, we'll do the work for this one here. You have 3. Your factors are 1 and 3. You have 12. Your factors are 1, 2, 3, 4, 6, and 12. So it might take you a little bit longer to do the factors. That's okay. I'm a math teacher. I can do them pretty quickly. But 1 times 12, 2 times 6, 3 times 4. Your greatest common factor is 3. So your 3 goes out front. You have subtraction now. So you put subtraction in the middle. Okay. So now you do 3 divided by 3. So it's just 1x. This is just a pattern. In this case, it's not always going to hold true. And then 12 divided by 3 to get 4. Okay. Moving on to H. We have, this is the last one of this type we're going to do together. So 15, and we have 20. So 15, your factors are 1, 3, 5, and 15. 20, you have 1, 2, 4, 5, 10, and 20. Your greatest common factor is 5. Okay? So when I write this out, the 5 goes out front. I'm now going to do all of this divided by 5. So 15x divided by 5 gives you 3x. And then this is plus, because this was a plus. Then 20 divided by 5 gives you 4. Okay, and that's done. So you are going to do all of exercise 1. You're going to do B and C as well. But I'm moving on to example 2 in the process. So example 2 is a little bit harder just because it has 3 terms now. But that's really the only difference is that you just have 3 terms. So you're going to want to find the factors for 2, 12, and 8. So your factors for 2 are just 1 and 2. Factors for 12, 1, 2, 3, 4, 6, and 12. And your factors for 8 are 1 times 8 and 2 times 4. Greatest common factor is 2. It has to be in all 3 this time. So the 2 is going to go here. That's your GCF. That's where that goes. And then here is what you divide out. So 2x divided by 2 is 1x. 12y divided by 2 is 6y. 8 divided by 2 is 4. Okay? So what you have here is you have 2x plus 12y plus 8, which is the original, is equal to 2 times 1x plus 6y plus 4. They are equivalent expressions, okay? So you determine the length and the width. The length is 2, the width is this whole thing. 2 times this here. Okay. So move on to the next page here. And you are going to do all of 2 on your own. Okay. We are going to skip this. Okay. And skip this. We'll come back to word problems next week. So exercise 4 here, they want to know what the opposite of negative 6v plus 1. So you have to do the opposite of each piece. Opposite of negative 6v is positive 6v. Opposite of plus 1 is minus 1. Okay? And that's all for that. So that's going to help with what we're doing next. That's why it's there. So flip. So using the distributive property, write an equivalent expression for part A. So part A was negative 6v plus 1. And if you remember, the opposite is like, when you have a negative, or if you have a negative, that means to do the opposite. So I can also write it like this. It's really weird, but they're actually equal. Okay, and you can also go in the opposite direction, which is what's going to be happening down here. So we're going to skip 5, and we're going to look at this 5, okay? So the difference here between this problem and what you had done on the front is that there's now a negative here, but it really doesn't change anything. Or that's what you had done for homework. So negative 3 times 2p, I mean negative 6p. And then negative 3 times minus 3. So negative 3 times negative 3p. This is spun rules. Okay. Same sign's positive. So it's actually going to be plus 9. Sorry, that's supposed to be a q. There. Okay, so plus 9q. So you, what you could do if you wanted to, because this is a minus, you can kind of keep change the whole thing if you prefer that. So you can start off this way and do, this is just all going to be changing because this is a negative. So you would change this, that, and that, and then distribute out the 3. And then do 3 times negative 2 and 3 times 3. If that makes no sense to you, ignore it, go with this way. But those are just 2 different options to solving the same problem. Okay. So what I actually am going to do is going to write a couple new problems on here for you to do instead. Don't want you to do that. I don't want you worried about these ones here. What I want you to do instead, so I'm going to give you B. It's going to be negative 4 times 3c plus 2a. C is going to be negative 2 times negative x plus 7. And then D is going to be negative times negative 3z, I'm running out of letters, minus 8x. Okay, so go ahead and complete these. So everything that hasn't been done except for the ones I have scribbled out, you want to go ahead and do. So it's B, C, and D that we just wrote on here. And then you have, on the first lesson, you have B and C still. You have this whole exercise 1. And then on this page here, you have A and B. So you have a lot of work to do. If you are done with all of this work, you will go back and work on lessons 1, 2, and 3, anything that's not done. And then from there, you'll work on the review of GCF or the calculator trick sheet if you have those not done as well. If you're done with all of that, then you may go ahead and work on the homework, okay? But make sure that you are done with all of that first. So your homework tonight is just that next page in the packet, except I'm going to cross out number 1. Okay. Everything else, though, you are more than capable of doing is right on the lesson. This is the stuff we didn't do. It's silly. I don't like it. It's not worth our time, to be honest. Okay. So we're crossing out number 1, but you're doing the rest for homework. All right. All right. Get to work. Bye.